Hello, everyone. Thanks again for the invitation. So I'm talking to you from the unceded territory of the Salish people here in Vancouver, where it's morning, and I'm representing here the Metacreation Lab. And today, what I wanted to do is to introduce you a few concepts and my analysis of the current situation of what's happening with generative AI, which is very, very popular and covered in the news almost on a daily basis, now a day. And I've been lucky enough to work in that field since the early 2000s, before it was that popular. And so I'll introduce you my vision of the field, and at the same time, of course, take that opportunity to present to you some of the work that we've been doing here in Vancouver, often with the help and resources of Alliance Canada and Compute Canada and all those great supercomputers that we have and we share here in Canada. What I'm not going to talk about today is AGI and the type of AI that can think better than us in every possible domain and is possibly going to take over the world. Instead, I'm going to talk about the type of AI that already exists, which is just this moving front of using computers to automate tasks that otherwise would take a human brain. And if you think about it, it started a long time ago where we automate things like multiplications. Nothing in the world but a computer and a human brain can do a six-figure operation, a six-figure multiplication, for example. And it's not really impressive nowadays to do that. In the 80s, AI was about automating playing chess. And then as we moved through the history of the field, we were able successfully to automate at human competitive level a number of tasks. What we don't have now is an AI that can do all of that. We have what we call a jagged type of AI that is really good at some things and not so good at other things. But AI, for all intents and purposes, is already all around us, and we use it every day, multiple times a day. The type of AI that I've been focusing on as a mathematician by training and a computer scientist, or as a theoretician, is creative AI, which is this idea of automating partially or completely creative tasks with algorithm. And we've been working on that at the Metacreation Lab since 2008. And while we can't really define creativity, and philosophers are still debating the concept itself, what we can define quite well are creative tasks, which are, in fact, by definition, those tasks for which there's no clear optimal outcome. And so it was an interesting problem for a computer scientist, because rational problem solving and the search for optimal solution in a given space is not applying directly to this type of domain. And those creative tasks, believe it or not, are extremely common. In fact, I would argue they're the most common task people do with computers, and they're the most common task people do in life. Having a conversation is a creative task in itself. Painting, drawing, choosing your clothes in the morning, all of that doesn't have a Pareto dominant front. It doesn't have a utility function that is very well defined. And so there is a subjective dimension to all of that. And trying to capture that with computers was challenging and interesting. And at the Metacreation Lab, we've been doing that across domain, this attempt to find algorithm to automate those tasks. So we've been doing movement generation, video game level generation, music generation, video generation, visual generation, etc. And we've been addressing that problem in an interdisciplinary, multidisciplinary fashion. At the lab, we develop new algorithms that we publish, the scientific contribution there. When they work, which recently has been much more successful than in the past, we work with the industry in Canada and abroad to apply those algorithms and deliver them to audiences and creators across the world. And we work ourselves with those algorithms, first-person view on them, and we collaborate with artists who use those algorithms and give us feedback. We really believe at the School for Interactive Arts and Technology, where I work here in Vancouver, in this notion of participatory design. We don't believe, even at the level of the algorithm, that we're going to end up with good systems and design nice systems if the people who are meant to use those systems later are not involved in the design of the systems from the get-go. And so that's something that we really are practicing ourselves in our research and that we promote at SIAT. So what I'm going to do today is talk you through some of the work we've done. And in doing so, I'm going to introduce what I think are the two main applications of generative systems and creative AI algorithm as they are now, and as you will see them develop further and further as those systems are deployed in the world in the next few years. The first family of systems I'm going to talk about are embedded generative systems, systems that are meant or that are aiming to generate in real time the right content for the right user. And we'll talk about those systems first. Then I'll talk about what is computer-assisted creativity, and this idea that a lot of creators are not going to use generative systems and do a sort of back and forth and interact with those generative systems to generate creative assets. And that's already very much the case. And we'll see what contribution we made there. Then we talk about the evaluation of those systems. If they are to be deployed at scale, which is ongoing and likely not going to stop tomorrow, then do they work? What are the promises of those systems? Yeah, maybe they lower the barrier of entry for beginners. Maybe they allow professionals to work faster and better. We'll see about that. And then more importantly, what does it mean in terms of authorship, in terms of acceptability? Are those tools and software more interesting to use, more satisfying to use on a daily basis for creative workers or not? And then we'll conclude with some open challenges and opportunities, and there's many in the field of generative AI and AI in general at the moment. So the first family of systems I will cover are embedded real-time generative systems, systems that are trying to generate the right content at the right time. A good example of the systems is the notion of musical agents, and more generally the notion of agents, which is became really popular last year and this year to the masses. But I did my PhD in agents and multi-agent systems in 2004, and so those systems are nothing new. This is the main notion actually underlying artificial intelligence, is this notion of artificial agents, which is very simply put the idea that we can design algorithmic and computer systems that can perceive their environment, often a software environment, sometimes in the case of robotics, a physical environment, and then act on this environment to achieve some goals that are given to them by the designer or that they generate by themselves. In general, agents are different from the software system in the sense that they are proactive. They can act in the environment without necessarily just reacting to a command. And so, for example, when you are into a word editing software like Word, nothing is going to happen if you don't click somewhere or type something somewhere. With an agent, things are going to happen if you don't do anything because the agent is acting in the world. So you all became, I think, familiar with this notion of agents quite recently through interacting with AI agents such as ChatGPT. Before that, there was quite a lot of agents made popular by being embedded in video games, often as non-player character. And those are all AI systems that needs to interact in real time with human and or other agents. Very recently, cloudbots is becoming very, very popular as an agent that can do pretty much anything you can do with a computer and an internet access, except that you can just use this AI and talk to the AI so that the AI works for you. Those agents are becoming quite powerful. In fact, cloudbot is not recommended you install it on your computer because it might wipe out your entire hard drive and create some catastrophe. So there's really a rise in power of those systems. In the Metacreation Lab, we've been working for decades on agents and multi-agent systems, but we've been quite good at developing musical agents. And you'll be surprised how rich and diverse the field of musical agents here. And there's a survey we published a few years ago in which we list 80 different architecture for agents that are just simply capable of listening to music on stage in real time and playing along, often with human musicians, maybe sometime with other artificial musicians, and improvise with them along. In fact, the way those agents are working is pretty simple and resemble very much the way human improvisers do work. They've been trained, so there's machine learning involved. They've been learning a vocabulary of sounds that they can use, and they've been learning the temporal structure of the music they've been listening. And so typically you train them on the corpora, on the corpus, on the data, on the music of a given composer, and they're capable of doing things such as simple reasoning, such as, oh, given what Philippe just played and what I just played, what would this composer play next to sound in the style of what he's been doing usually? And with that in mind, we have those agents that are capable to play and make music. Here, for the sake of clarity, I'll just show you an example of an agent playing in a festival, Ars Electronica, a few years ago in Linz. The agent here is alone. He's been trained on the music of our friend Mehmet from the audiophile group in Istanbul, and he's playing in the style of that composer. And you will see that here the agent is alone, but he's interacting with the video agents. And so there's a real tight synchronization between the audio and the video, something that would be really hard for human operators, human artists to do. All right, and so with those musical agents, that was an example of the agents playing alone, and it's quite good at generating music, really. The interest is really to play with them in real time. And here you can see a picture of us playing in Montreal at the MUTEC Festival in the Society for Art and Technology. If ever you have the chance to visit this room in Montreal, it's a dome projection with specialized speakers, like 95 speakers. And it's quite a thing. But here what I'm exemplifying is this notion that we have now AI that can generate the right content in real time. And that's the notion of co-creation when you apply that to creative tasks. Because when the agent does something, I won't be able to curate it. If the agent starts playing something that we don't like, well, too bad. We're on stage in front of an audience and we have to live with it. So this notion of creation is this idea that agents, human and artificial agents, are going to work together towards a creative outcome, and the AI will have an input in that creative outcome as a co-author in some sense. So we've been working with that, and we got some awards, and we've been refining those agents architectures and giving them different behaviors. Is the agents following what the musicians are doing? Is it trying to complement what the musicians are doing? And then machine learning as well with adaptive systems. Maybe we want to tell the agents during rehearsal, hey, this was great, we want more of that, and this was not great, let's do less of that, a little bit like we do when we interact with human musicians. And so this is a first example of this type of AI that I think is going to be increasingly present, that generate in real time answers or content for the users. Another example that we were quite early at developing in 2017 is movement generation. In a lot of nonlinear media, video games in particular, if you have millions of players playing World of Warcraft 20 hours every week, how many actors do you need to motion capture in order to generate all those animations? The answer is way too many. And so what we can do instead is do motion capture of a number of very different but really good actors and performers, and then create a latent space and generate new, by interpolation or by extrapolation, new movement styles and sample that domain, and then we can control, you see here, the perceived valence and arousal, the emotion, whether the actor is walking and being happy or walking and being sad. And here you can see the the character becoming miserable, and controlling that in real time as value. And then we can regenerate motion graphs that we can embed in a game if we want to. So those are two simple examples of this idea of embedded generation. And if you think about it, interactive systems do call for those type of generative systems. I just mentioned to you, there's now economical reason why video game companies would want to go generative, because generating all those assets manually is really costly. So the economical and pragmatic reason for generative systems. And that's answering the why question. Why are we making those generative systems? And as we move from linear to interactive media, there's really an explosion, an exponential explosion of the number of assets needed. If you make a movie, a linear media, you write a book, or you make a song, there's a beginning, a middle, and an end, and it makes sense that human would take care of every second of content there. But if you make, a video game and you have millions of players playing hundreds of hours each, then all of a sudden things become a little bit different. But I don't think those are the main and the most interesting necessary motivations. They're certainly part of a lot of the application of what we do in creative AI. But there's also a more interesting promise that those type of system holds, which is the notion of really adapting the experience and the interaction with the content to the user, and this idea of personalizing the experience. And that's the idea of taking into account the notion of flow. In cognitive psychology, one of the main concepts has to do with the fact that to get people's attention, to get people engaged into an experience, whether it's learning, playing, or even a conversation between humans, you have to be in the flow zone. This is certainly true with our musical agents and musicians. Musicians have to be in the flow zone for things to work well. But if I take the example here for a second of a video game, I can explain this notion of flow by saying, well, if the video game is too easy, there's no challenge whatsoever, it's boring, I'm not going to continue playing that game. On the reverse, if this video game is too hard, it's discouraging, then I'm going to stop playing. In order to play, I need to be challenged exactly the right way. I need to be into that flow zone. And eventually that flow zone changes over time. Some people, though, are fast learner. That flow zone needs to move toward more challenging content really quickly. Some people, like me, are more slow. And if this video game becomes quickly too complicated, you're going to lose me. Maybe I will learn slowly at the beginning and accelerate later. Maybe I will learn fast at the beginning and then plateau later. What I'm saying here is that the path of that flow zone is different for everyone. And with AI, we just now have the possibility to eventually generate the right content at the right moment to keep any user in the flow zone. And this is not just nice idea. This is thing that we do research around and we show actually works. And we did one actually video game level design competition by using this type of ideas, where we look a little bit how challenging a level is going to be for a player, and we measure where that player is at the moment, and we generate the right content for the right player at the right time. We also have agents looking at the video game and generating the right music at the right time. And we show empirically that indeed that provides for better immersion, more enjoyment, more emotion during the game play. And we can therefore apply those ideas of tracking the flow of an interaction and generate the right content at the right time for the right user. And we do that not only in a creative way when it comes to play, but when it comes to learning, when it comes to health and wellness, there's ways to go beyond mere generation, generating content that is of good quality, and move toward functional generation. That's exactly what we've been doing in the lab, collaborating with our students and alumni with a number of companies that they have created now that have to do with, here, for example, generating soundscape. Depending on whether you want to relax or you want to focus at work, maybe a different type of soundscape will work for you in that case. And so we generate a content that would work for a given person in a given circumstance. We do that now also for breathing and breath work with a company based here in Vancouver called Prana, in which we use biosignal so that the AI has a feedback that tells if indeed this type of content is achieving to release your stress or relax you, or change your heartbeat and your breathing patterns. And so that's the notion, and you will see I predicted a lot more of those type of application, this idea of functional generation, where we have AI systems that generate the right content at the right time. In fact, we know that music therapy and all sorts of intervention do work, but you need humans. And there's not that many, there's 8 billion humans, and music therapy would work on all of them, but there's only that many music therapists. And so therefore with AI, we have here a potential to democratize a number of things, interventions and types of interactions by using AI to generate the right content at the right time. We also work here in Vancouver with Kik, who is using virtual agents to try to get type 2 diabetes patients to follow the protocols that we help them to alleviate their health issues. And we've been also using virtual agents recently in VR chat. That's a paper coming at the next edition of CHI, the Human Computer Interaction Conference, to reduce foreign language anxiety, because for a lot of foreigners that have a strong accent, like I do, although I'm not Canadian, it is easier to interact with those virtual agents. It is less intimidating and create less anxiety to interact with those virtual agents and be corrected by them than it is with human participants. So there's all sorts of applications that are already being developed at the moment that are applying this idea of using AI to generate the right content at the right moment. And in a way, we move from a world in which AI was mostly used to recommend content. That's what happens when you Google something. A search engine recommends you which website to go to get this information. Netflix tells you what to watch next. Spotify recommends you what to listen to next. So that was really the previous use of AI, and is going to continue to be the case. But we're moving and adding options here where now the AI would not just recommend content to you, but actually generate the content for you. And you can see that happening in Google right now, where if you Google something, you get an AI answer at the top. And Google is getting sued actually for that, because basically they undercut their market. You're supposed to use Google to search for, this is a search engine, to search for a website in which the information you want could be. And then you click on those links. Now, if Google goes to get that information from those websites and put it on top of your results page, then people don't click on those links anymore. And that's a problem. But I'm not a lawyer, so I won't comment too much on that. So that's really what I wanted to say about this first family of creative AI algorithm and the way they applied, with the hope that we are moving towards adaptive, personalized AI content generation. The second family, which is very much already in place and being deployed as we speak, is the notion of computer-assisted creativity, where we're going to help creators by embedding, often augmenting existing software and existing creative pipeline, and replacing some of those part of those creative pipeline using generative algorithm, often where there's going to be a back and forth between a user and a generative algorithm, in which the user is not going to generate the content anymore necessarily, but is going to guide the generative system toward the content that is desired. In a way, this is nothing new, but it became really, really popular, and there's really been sort of a rise in popularity of those type of system in the last few years, because of the rise of prompting and prompt as an interface to control those systems, by which you would be able to describe an image, a piece of music, any type of content, and the system would generate it for you. In reality, although it's been made popular by mostly Californian big AI companies in the last few years, of course, in the lab, we have been working on those type of computer-assisted creative systems for a long time. And here is an example from 2012, so 10 years before ChatGPT, of a prompt-based interface we developed at the Metacreation Lab for computer-assisted sound design. Here you describe how a scene, a sound design scene, often a scene of a movie, will sound. Maybe you want to listen to kids playing in the forest, and then you decide how long it's going to be and what are the perceived emotions that are going to unfold. Maybe it starts it's happy and it finishes sad. It starts calm and it finishes very eventful. And the system is going to put together different tracks with different sounds of background and foreground and try to make a mix that works for you. You can then download that mix, edit, keep some of the sound, remove some, and change it, edit it yourself, or you can regenerate some content if you don't like it. So, for example, if you want the system to generate the soundscape of a waterfall in Thailand, it might sound like this. If you want to generate the sound of a city in the bush, on the other hand, it might sound like that. And of course, you can make requests that are more creative and try to be playful with the system. And often when we give the systems to artists, we find that creators always find their own way to use those systems. So here's a really early example. You can try it for yourself. It's still online, audiometaphor.ca. It's a collaboration with the sound bank that is freesound.com, which is based in Barcelona in Spain. So that is the sound that we use. It's pre-deep learning, but it works pretty well. In fact, when we evaluate that system, it's really useful to sound designers. And I'll show you some numbers later when we talk a little bit about evaluation. However, we show that it's not as good, which is good news, as a professional sound designer. But it helps a lot in retrieving those sounds, cutting those sounds, classifying their emotion, and classifying what is background and foreground, and do a lot of the work that is the most tedious part of that particular creative flow. And often that's what we want in creative AI, is not necessarily to automate, and certainly often not to remove the human of the loop at all, but to take some of the part that might be really time consuming or less interesting of a particular process and try to see if we can partially or completely automate those parts. So that's the first example that is early, also to show that, of course, everything happened in labs before it become commercial successes. And then, so prompt engineering and prompt-based systems have been becoming extremely popular. And then here is an example of Udio and Suno is like that, of a prompt-based music generation, audio generation system. And those are really powerful. For example, I can ask for a catchy rock song about the presentation I'm doing to you today at the Digital Research Alliance of Canada, and it might sound like this.
Metacreation, it's the art of the new. Join the revolution. poor Philippe's taking the stage. You see, with creative AI, he's the key in the Metacreation Lab. Dreams take flight at SFU, he's shining bright. Digital research making waves. Compute Canada when it varies.
So those systems are really, really good. So you can generate music in any style, and you can manipulate very much. You can download the stems, you can change the lyrics, you can upload a melody or part of the music, and it will do the rest for you. And it all works prompt to audio. And if you think, because you're doing contemporary music and something experimental, that those systems can't generate that type of content, then you would be wrong, because they actually can generate all sorts of content. And so the musicians, and maybe most of them the musicians, the stakeholders, the people who make the money on the behalf of the musicians, were really upset about those generative AI systems in all sorts of creative domain. And there's a lot of lawsuits going on at the moment. I was called myself to be a witness expert on some of those cases. We had like Sony and Universal against Suno and Udio, and a lot of those were based on this idea that those companies were accused and are still accused to having scrapped the internet and all sorts of copyrighted content to train their model. And that's really the big data problem that we're facing. And there's a lot of companies that are therefore not capable of really pushing AI in the world and applications of creative AI, because they would be sued, and there's legal issues that needs to be addressed. The other issue with those type of systems is that there's now a flood of AI generated content of rather good quality, although some people get tired of it, out there. And there was already 20 to 40,000 new songs made by humans, every day, literally in the world. And now there's double or triple of that because of AI. There's also this legal issue that in Canada and in the US, prompting alone doesn't give you ownership or copyright over the content. In other words, prompting and asking through text for a given content doesn't make you the author of that content. And so there's issues around them, and prompting itself as an interface, the text box, has been criticized by a number of researchers and practitioners. So at the Metacreation Lab, we've been developing some model as well, and we've been taking part into the deep learning revolution, but we've been working on alternative to prompting and the hegemony of the text box itself. I'll give you an example here of computer-assisted composition, in which we train systems, in that case, a transformer, a GPT-2 architecture, but not to generate or to take text as an input, but to generate instead music. And here it's not audio, it's symbolic music generation. It's the composition that we generate, and then humans will have to interpret those composition. And possibly the best model at the moment is our MIDI-GPT, was published at AAAI 2 years ago, and it's good because it's been trained, and it's often the main differential in those type of system, is been trained on Digital Alliance of Canada, on Compute Canada, but it's been trained on the largest data set of compositions. Here they're encoded as MIDI files, but you can think of them as scores, musical scores, and we have released the largest data set in that domain. Under fair deal and fair use, as researchers in Canada, we have the right to do so. Then, with a bit of innovation in the representation, we can train a model, and then that model doesn't have the data, and we can show that that model doesn't do copyright infringement, and then therefore we can eventually potentially exploit commercially that model. And that's exactly that loophole between the training and the fact that the model doesn't really have the data that a lot of companies are trying to use, and that's why they work with researchers who have the right to scrap the internet in order to get to those models. Here is some early example of the model at work, so that I can explain to you what it does. And here, instead of prompting, you give it some music as input, and then you can regenerate, add tracks, and manipulate that music as much as you want. So yeah, with that type of system, instead of prompting with text, you basically give music, often your music as a composer, but you don't have to use it ethically. You can use copyrighted material like I just did with the Beatles and some other funky tracks. You can add some tracks, remove some tracks, resample some bars, and the idea with computer-assisted creativity is that there's going to be a back and forth, and you don't really generate the content or create the content yourself, but you interact with the system, and there's all sorts of controls we can deploy. So those are really powerful systems that I've been learning about all of the music human composed. It's sort of a superhuman composition assistant. And you know, as a researcher, you've done something that works when the industry is really interested, and here we've been working quite a bit with companies doing computer software for game music composition. In video games, there's a lot of repetition and variation. We just got a grant with Audio Kinetics in Montreal, working on those type of systems, and the composers are definitely involved, but eventually you want to use AI to help composing some of the variations of the music the composer does, or some transitions between different parts of music. And the combinatorics of those transitions make that using generative system might make sense. We worked with software company like Teenage Engineering. A lot of people buy synthesizers in this case, or software. They want to become musicians, but they don't necessarily know how to compose. They might be able to use the help of those systems, and that's one of the promise of those systems for computer-assisted composition, is to lower the barrier of entry for beginners and to make professional faster and better, allowing them to explore quicker, more creative territory. So we've been collaborating with Cubase Steinberg, a product by Steinberg, and doing some evaluation of the system I'll talk about in a second. Here is an example of the system being used to remix and make some new composition, original composition based on Mozart, which is now in the public domain. You can use the system and try it for yourself. It's called Calliope, and the model is online like that, with an interface that is not as developed as the one from those professional companies, but still useful. Here is the example. So you see the idea. You can use this QR code if you want to try the system for yourself with your own composition or you can upload any MIDI file. We've been working with musicians, we've been releasing albums, we've been contributing to the AI song context with these systems and other systems. There's a whole ecosystem of music generation here, but I just wanted to take this example of computer-assisted creative systems. We also do systems for sound design, and eventually these type of systems to partially or completely automate the making of creative tasks by creators is being applied to every possible creative tasks that can be computer mediated. And in fact, this is a game we can play. If you can think of a task that is computer mediated for which there's no AI, you let me know, because there's none that I know of. And so here I took example in sound design, music composition, but any task in architecture, design, art that is computer mediated will already have one or several systems. In fact, we think that there's been quite a bit of overshooting in terms of investment in those type of areas, and it's not quite sure we're going to recover the amount of money that has been invested there. There's all sorts of companies in every possible domain for every possible modalities that are working on those type of creative AI algorithm. And so because it is so prominent and being deployed in every domain for every creators, we're really interested in evaluating those systems. And of course, we can evaluate those systems just looking at the real world and whether that music is good and whether it works. And indeed, right now, there's AI artists that are in the top 40 and in the charts routinely, and it seems to be working. And when we work with artists ourselves, we have the privilege to collaborate with a lot of them. We get a lot of feedback, and we find indeed that those systems are working. So we want to be a little bit more systematic. We got some funding here to work from the Canada Council for the Arts to work with artists. We also organize an artistic residency where we have composers coming to the lab and working with our systems every year. That's supported by the Institut Français of Canada here in Vancouver. But of course, as academics, we're interested in maybe making more formal scientific studies of those systems. And here we did verify, indeed, if we use, for example, audio metaphor, but we have other examples, that the promise that those systems will allow beginners, will lower the barrier of entry for beginners, seems to be true. When we teach sound design and we allow students to use AI as part of their sound design, we find that they work faster, and that the work they do is both subjectively they like it better, but also when we grade them, which we do at the university, they perform better. And so here there is really an improvement and some value for the systems. However, even for beginners, they find that they're not necessarily the author of the work that comes out, and that's really a dimension that we're really interested in. And we did other studies this time with professional composers, people who make a living out of using those software. And if we put generativity and AI in those software, we're not interested just to see if the system works, because it does, if it allows them to save time, because it does. But more importantly, is it the case that there's enough control so that they can be expressive through that system? Is it the case that the music that is being made using that system is their music? Or is it the AI music and it's been just possible to make interesting music, but it's not their music? Or is it a collaboration between them and the AI? How do they feel about it? And more deeply, the phenomenology of using the systems. If you have to use that system every day for the rest of your life, which is likely what's going to be pushed on a lot of workers, how do you feel about it? How do you feel about going to work in the morning to interact with this AI all day long? And what we found, in fact, in a rather extensive longitudinal and long studies here, is that those composers don't have a lot of problem with that AI, and we were sort of surprised about that, and we found that they do retain authorship over what they generate when they use the AI, often because those professionals, they know how to compose, and they use the AI much more as a what-if machine. Oh, what if I had a marimba here? Oh yeah, no, I don't like this one. Oh, that's interesting, I can use that. And then they would compose a new part because they can. So while for beginners it allows to lower the barrier of entry and for them to make content that they couldn't compose otherwise because they don't have the skills, for professional it has a different a different set of features. We've also been looking at evaluating how the audience react. And in fact, here I won't surprise anyone, but it's been already, almost 15 years that we were showing that people can tell the difference between music composed by a human and music composed by a machine. And then the people, the professionals can't tell either, and the people, nobody can tell above chance basically what's happening. And then we also were measuring the bias. If we tell people that it's made by a machine, do they think differently of it? And here the research is ongoing and the conclusions are hard to reach. But those are the two families I wanted to talk about today, and I'm going to wrap up in a few minutes this talk. There was this first family of systems that have the promise of generating the right content at the right time, embedded generative systems, agents, and those other systems that are assisting creative into accelerating and making the creation of content more efficient, both by lowering the barrier of entry for beginners and allowing professionals to explore a little bit more. Altogether as well, those systems are moving us a little bit away from the traditional type of creative studio, which is often made of creative software on which creative workers click on buttons, often the same button in the same order, to the point that some people talk about the click factory that it has become. Now, those are the promise of those two families. There's also issues. I talked briefly about the notion of big data and the fact that a lot of models are trained on possibly stolen copyrighted content, and there's a lot of lawsuits regarding that. Often they settle before actually arriving to court, and at the Metacreation Lab, we've really been interested to see, is there any other alternative? And there's indeed a diversity of AI, and it's just often Californian for-profit companies that make you believe that everything has to be in the cloud with supercomputers and really big models. But when you ask artists, what you find is a lot of artists, they don't want to use a model trained on everyone else's data. And in fact, that model usually is incapable of doing the exact aesthetic they want. What they want is to be able to navigate, adapt, and craft their own model, not trained on big data, but trained or fine-tuned on small data, their data. They don't want to upload any of their work in the cloud because it's their artwork and it's precious to them. And they don't want to learn Python and PyTorch. They want a no-coding environment, graphical interfaces, that they can work locally in real time and do direct manipulation. Often they want free software and, if possible, open source, so that people who know programming can check that the software does what it says and nothing else. And if you try to find a system that does all of that, then you will find exactly none. And so we made one, and it's called Autolium. It's a neural visual sensitizer, and it indeed allows any artist without no technical knowledge to train locally and to run locally a model with their own data. A few pictures, 50 images, 100 images, 200 images. Some videos, we can extract the frames from the videos and get thousands images really, really quickly, and generate model. And we're interested in this idea of empowering artists to craft their own model, go back, find out that the first model is not the best model, and then change the data set a little bit and train again and exploit those model, and have this access to direct manipulation of that latent space that they build of their own work to find those nuggets, save them as presets, and exploit them into artworks. And so we've been working ourselves with those systems, collaborating with a number of artists, organizing exhibitions. We're giving workshops all over the world with this type of system. There's really tremendous domain, because for a lot of artists, those big models are not satisfying. For example, if you ask DALL-E here on the right to generate Arabic calligraphy, it will be beautiful, but it won't be Arabic characters. It will hallucinate something quite offensive, actually, for people who are interested in calligraphy. And so if you want to do Arabic calligraphy, you have no choice. You have to train your own model on your own data. And that's exactly what we do with our students, in this case, Arshia Soban at the Metacreation Lab. The system runs in real time, so we can use it in performances, and we have been using it on stage and in performances, and we've been teaching that system in art school across the world, especially for communities whose culture, aesthetic is not necessarily represented in the data set that those big models are trained on. So instead, here on the top left of navigating through prompting an existing model trained on scrap data, you can train your own model, craft your own model iteratively on your own data, whether you curate them or you create them. The last thing I'm going to talk about before concluding here, I have only a few minutes left because we got retarded by those technical problems, is fear of automation. And that's in a way showing that there's real disruption happening with those AI systems. A lot of people, writers, actors, voice actors, musicians, designers are afraid, and we see the impact of those systems already. And that's nothing new. Each time there's a new wave of automation, there is a serious pushback. At the time, when we automated the loom, people were breaking those machines, and then the silk worker later on in France, the same thing, and eventually we recovered from those disruptions. In creative domain, the same thing. When musicians were replaced in cinemas and theaters by gramophones and record players, there was some investment by the American Federation of Musicians against those trends. Yet at the same time, new activities are created, and now you can get a degree in prompt engineering you couldn't 10 years ago. And so it's hard to tell what the dynamic of those disruptions is gonna be. So to conclude, while there is some promises from the systems, there's obviously a lot of challenges. We do believe, though, that there's maybe some solutions in the diversity of AI possibilities out there to address some of those issues. I talked to you today about the problem of big data, and then the issues regarding those AI systems. So to conclude, I wanted to say that I remain optimistic, and that I still believe in anthropocentric instrumentalism, this idea that those are tools and we get to design the tools we need and discard the one we don't. Now, at the same time, also acknowledge that those systems already have deep social political implication, and that unfortunately, like for the computerization of society, there's been very little democratic debate or democratic decision. In other words, we didn't vote that everyone will use a computer 8 hours a day for the rest of their life, and we didn't vote or decide that these AIs were either needed nor that we should deploy them in mass. And so there's a lot more public debate needed, and I'm happy to address you and inform you about those developments today. I want to thank all my colleagues and students with whom this work would not be possible. And if you want to hear more of a strong French accent, then I have some courses that are free and accessible online as well. In fact, at SFU, we are opening now some of our human-centered artificial intelligence courses to anyone. And so people from Alliance Canada and from anywhere in Canada could take some of those courses, because we now recognize at the university that your bachelor degree and or your training might not suffice for the next 40 years. And finally, I also want to point, because this is the right audience to do so, about the movement that is happening here in Canada and everywhere in the world around trying to think about AI as a common, a little bit like roads and electric grid, as opposed to be only a for-profit enterprise, often non-Canadian, and try to think of what it would be if AI was a public resources, as opposed to be a privately run sort of set of enterprises. And so I'm happy to talk about that. We just released a report called the AI Common Report with the RTI group. I'll put the link on this slide, and I'll be happy to share my slide later. And so with that, I want to thank all my funding bodies, NSERC, SHERC, and the Canada Council for the Arts, because we get the chance to get supported by all of them. And of course, the good people of the Digital Research Alliance of Canada, without whom none of those models would have been trained in the first place. Thanks a lot, everyone.
Thank you so much, Philippe. Fascinating talk. I really appreciated your discussion of authorship, and then also touching on this issue of local models and how important that is to bigger concerns about trust and safety in AI. We're running low on time, but if there was like one or two questions that people had, you can put them in the chat or put up your hand. Yes, so there's a question here about what extent do you think curating ethical public data sets is critical to local machine learning efforts, images, sounds, etc.
Yeah, so we've been pushing a small data model crafting agenda, but we recognize that in a lot of cases, a small data alone will not give you the results, and so having a base model is a good idea. And indeed, there's a lot of ways to be more ethical about creating data sets, and so there's industries doing that. And making effort in that way. Microsoft, Adobe, like with Firefly, they retribute the artist, so they have the largest database of stock images, and if the artist opt in for the material to be trained, then a little bit of money trickle down to them when the model is being used. But this is sort of the same as streaming for music. It's usually not enough money to actually make any significant progress toward a living wage. And so that's not really a solution. Then you have public domain and Creative Commons and lots of material that is not copyrighted and therefore it's ethical to use. And I agree, more efforts are needed. Here I want to mention that in Vancouver and in Canada we have the Internet Archive of Canada, and I wanted to say that because I talked to them yesterday. Alliance Canada would be a great partner with the Internet Archive. It's the second largest repository of data after Google in the world. And they've been making an extremely interesting effort to digitalize Canadian books in particular, all sorts of Canadian content. So there's a version called the Internet Archive Canada, and that is public data set. Now, is it ethical? I don't know, because they archive the entire internet as well, and so they do a lot of things with that consent, but they implement the right to be forgotten. So if you want to be removed from the data set, you can. Not everyone agrees with copyright as an idea, and the laws that ensure as well. So all those issues regarding data set, they're important, they're critical, and we need to have discourses and possibly, and we start to equip ourselves with regulations around what is possible and not possible. I have to say, here in Canada, with privacy laws, we are pretty advanced, compared to some other nations, and that's the last part of my answer, is that for a lot of issues regarding AI and certainly issues regarding data, we live in a world of state nations that are in competition at the moment. Humans are not yet at the stage of asking for humans what humans should do on Earth and how we're going to organize ourselves, and international institutions are rather weak, and so therefore we fall prey to the problem that you have to harmonize not only one set of legislations but worldwide, international laws, and that's way easier said than done, unfortunately.
Thank you. And then I think we'll just take one last question. So you have, what are some of the main pain points artists speak about when they are using creation tools? So these compositional or interactive tools.
Yeah, well, often it has to do with interface design and what set of parameters and controls you give access to. So if you give too many controls and too technical type of controls to a beginner, then you lost the beginner, and he might ask the system to do something that the system can't really do because the request is ill-formed. On the reverse, if you don't give enough control and there's only a generate button somewhere to a professional, then they're going to complain because they want to control everything. And so there's always these tensions when it comes to interfacing those systems and deploying them in the world, is that every user is, in a sense, a little bit different, and then you would want the interface and the system to really adapt to the user, and we're not quite there yet. And so there's those rigidity that are common with software, where you feel sometimes that you have to work for the software and you adapt as a human because you're flexible to the software more so than the software adapts to you, and we like to reverse those dynamic, but that's often the pain point. And the second one that I would want to mention, that is sort of very general, is the last mile problem, is that we find, and that's what we think, that maybe those investments were really unwise, that everyone dream of a world in which this AI can really be useful and help. But it turns out in every domain, it doesn't quite work. everyone thinks everyone else can be replaced by an AI, but everyone agrees that themselves can't. Because, and that's even for translation. Things where you think AI kills it, not at all. If you ask a translator if they're worried, like, no, absolutely not, because they can't do this and that and that. And then everyone else thinks translation, is solved. And that's pretty much the case, as far as I know, for every possible domain. And so you get this situation where we have these systems that are pretty good, but not quite as good as you want them to be to really use them, and you actually lose a lot of time trying to use them. And there's also studies now showing that people think they gain time using AI, but if you measure the time they spend, for example, for coding, there was a great study showing that they're actually slower than they used to be, and so you're not necessarily winning all the time. And so I would say the last mile problem might be the main pain point. And so in a way, those AI in creative domain are really useful for prototyping, for ideation, but they're not really necessarily the best for actually generating the content, because almost always artists would be frustrated to not ever get exactly what they want in terms of aesthetic out of the system. And so there's still a lot of value into human creativity, for sure. And I even would go further and predict that human creativity will become more valuable, a little bit like craft became valuable when we started automating the making of object. If you want a handmade ceramic or handmade, hand-blown glass now, it's much, much more valuable, precious, and regarded positively than a machine-made one. While before, there was nothing special about crafting objects. And so there's possibly going to be, as we get invited with synthetic content, there's going to be some evaluation and valuation of human-made content.
Yeah. Well, that feels a little hopeful.
Yeah, let's finish on
the doom and gloom about AI taking over the world.
That's right.
Mm-hmm.
Okay.
Yeah, well, I want to thank you so much, Philippe, for sharing your time and your knowledge with us. And yeah, thank you so much, everyone else, for coming.
Absolutely. Thanks a lot, Maria.